Hey, you guys. Welcome back. Today we're going to go over some decimal operations. These problems are actually the problems from that independent practice that we did the other day in class. It's the one that I gave back with all that feedback written on it and circled any wrong answers and tried to circle any incorrect work if I could find it. So these are those same exact problems. If you have it still, it'd be a good idea to pull it out. And then you can double check what you did to compare it to what I do and see where maybe you went wrong. It'd be really helpful. So before we do that, though, fact 22 about me. My favorite city is this city right here. This is New York City. This green in the middle right here is Central Park. It's right in the middle of the city. I went here maybe like 3 years ago on my birthday with a couple of friends. It was the coolest trip of my life. I loved it so much. Every single second. Just being in New York City was incredible. I got to go and ride the subway. I got to go and see all the big sites for movies and TV shows that I love. I got to go and see a few Broadway shows, which was awesome. I got to go and see a couple live tapings of TV shows, which was really cool. I got to go see Jimmy Fallon live. It was incredible. Loved it. It was awesome. So, this is my favorite city. I wish I could live there. It's crazy expensive. So, maybe at some point in the future I could go live there. But right now, I'm going to stay in Alpharetta and maybe just go back and forth to visit. Hopefully, within this next year, I can go back and visit again. It's the coolest place. Love it. So, anyway, let's get back to the math. So, let's go over some of these problems. This first one is an addition problem. These first two are addition problems. So, whenever we have addition problems, all we do is, let's see, actually make that a little smaller, the size of it. That's perfect. There we go. Now let me move this out of the way. There we go. All right, so with addition problems, all we're looking at is if the signs are the same signs, we set up an addition problem. If, however, the signs are different, we set up a subtraction problem. So look at this first question. It says negative 15.3 plus negative 0.47. The signs are the same. I'm going to set up an addition problem. So 15.3, 0.47. Notice how the decimals line up because that is really important. I'm going to add them up and I'm going to fill any missing spaces with zeros. I'm going to add these up. So 0 plus 7 is 7. 3 plus 4 is 7. 5 plus 0 is 5. 1 plus 0 is 1. Then I bring my decimal right down, and the decimal stays lined up the entire time. It's perfect. Now, the signs here are both negative. Whenever I add two negative numbers, I keep the sign from the problem, and my answer is negative as well. Look at the next one. Oh, these have different signs, a negative 13.2 plus a positive 25.6. When the signs are different, I'm really going to set up a subtraction problem. So let me get my subtraction problem going. Now, whenever I set up a subtraction problem, I'm looking for the larger number to go on top. Technically, every positive number is larger than every negative number. But whenever I'm doing this, I'm thinking about which one has the greater absolute value. Whichever one has the greater absolute value, that's what I'm going to put on the top. All right, this has an absolute value of 13.2. This has an absolute value of 25.6. It's a 2. So this is the number I'm going to put on top. The larger number has to go on the top because when we subtract, it's really important to subtract properly. The larger number is on top. So 25.6, 13.2, and then I'm going to go through and subtract these. 6 minus 2 is 4. 5 minus 3 is 2. 2 minus 1 is 1. I bring down my decimal exactly where it was. Notice how it's still lined up perfectly. That's exactly what I want. And I keep the sign of the larger number, or the number with the greater absolute value, right? So in this problem, it's this positive number. So my answer is positive because that is the sign of the larger number. All right, let's scroll down some. And there we go. Let's get back to the pen. Move this out of the way. There we go, perfect. All right, let's go and look through this one. This is a subtraction problem. Subtraction problems are the exact same as addition problems. The only thing is that there is one step before. I have to turn this into an addition problem by using that keep, change method, or add, the opposite, add the opposite. So let me rewrite it so we can all see it. Keep the first number the same. Subtraction becomes addition. I change the sign of the second number. So now look, this is an addition problem. Great. I can use the addition rules. The signs are the same, so I know I'm going to set up an addition problem because I have the same signs. I'm going to add. So let me go line them up. 17.8, 2.54. Notice how the decimals are lined up, and I have empty space on either side. Those just get filled in with a 0. Make that a 0. There we go. Then I get to go through and just add. 0 plus 4 is 4. 8 plus 5 is 13. Carry the 1. 7 plus 2 is 9. Plus 1 is 10. Carry the 1. 1 and 1 gives me 2. And then I bring down the decimal and keep it straight in a line, perfectly lined up. That's exactly what I want. These numbers from the problem are both positive, so when I add two positives, I keep a positive answer. Let's look at the next one. Oh, it's another subtraction problem. Once again, I turn subtraction problems into addition because I know the addition rules. So, keep the first number, negative 23.7. Subtraction becomes addition. I change the sign of the following number. So this is my new problem. And look, this is an addition problem. I just learned about those. I was just talking about those. Whenever we have the same signs like this one, we set up an addition problem, look. But whenever we have different signs, I know I really have to set up a subtraction problem. I know it's kind of confusing to remember, but it is really important. So whenever I do this, I'm going to put the largest number on the top. And really that means whatever number has the greater absolute value. So the number with the greater absolute value, if I was going to take this one and this one, this would be an absolute value of 23.7. This would be an absolute value of 35.9. This is the winner, so that one goes on top. I have to put the larger number on the top whenever I do these subtraction problems because in order to subtract properly, that is the case. That's how it has to be, okay? 35.9 minus 23.7. 9 minus 7, 2. 5 minus 3, 2. 3 minus 2, 1. And I'll bring down the decimal exactly where it was. And I'm going to keep the sign of the larger number. In this case, it looks like it was the positive. It had the greater absolute value. I'm going to keep the sign of the positive number. So 12.2 is my answer there. Perfect. Let's look at this one. We got multiplication. So whenever I multiply, it's not like addition where I have to line up the decimals. When I multiply, I can ignore the decimals. They only come back whenever I fill in my answer with the correct decimal placement. So 13.4 times 2.1. And notice they do happen to line up here, but they don't have to. It doesn't matter. So let me go through and start multiplying. 1 times 4 gives me 4. 1 times 3 gives me 3. 1 times 1 gives me 1. And then I had to put a 0 right here because I'm moving from this 1 place value over to this 2 place value. So I'm going to start in this space. 2 times 4 gives me 8. 2 times 3 gives me 6. 2 times 1 gives me 2. Let's add these up. I got 4. I got 11. Carry the 1. I got 2 and 6 gives me 8. I got 2. So I'm going to go through and figure out where my decimal goes. Now, I'm not just going to see that it's right here and bring it straight down. That's not how we do it with multiplication. If this was an addition problem right here, we would. This is multiplication. The way I figure out where my decimal goes, I'm going to go look in the problem. I'm going to count up how many numbers there are behind a decimal. I got 1, 2 numbers behind a decimal. I want 1, 2 numbers behind the decimal in my answer. And then go double check if your answer is positive or negative. I got a positive number times a negative. That's going to give me a negative answer. That's what we're looking for here. All right, let's look at this one. 1.52 times 0.2. Once again, whenever I multiply, the decimals don't have to line up, and I'm really just going to make sure I line up with the right edge of the problem. And I always put the number with the most digits on the top. 1, 2, 3 digits in this one. 1, 2 digits in this one. So the 1.52 is going to go on the top. It technically doesn't matter. What number goes on top, you'll get the same answer either way, except when you do it this way, you're going to have a few less steps to take when you're trying to get your answer. All right, so it'll be a little easier for you. Let's look at this. I'll go ahead and start multiplying. 2 times 2 gives me 4. 2 times 5 gives me 10. Carry the 1. 2 times 1 is 2 plus 1 is 3. This is a 10. That was a 0. And I could go through and do all the 0, 0, 0s, but I really don't have to because when I'm adding these up, those zeros don't do anything. So I really only have this 304. Let me go and look and see how many numbers are behind a decimal in the problem. I got 1, 2, 3 numbers behind a decimal. I want 1, 2, 3 numbers behind a decimal. I'll put a 0 out here in front. And my answer is going to be, oh, a negative times a negative gives me a positive. That's great. I get a positive answer. Excellent. Now, let's look at the last couple down here. These are division problems. Let me scroll down just a little bit. There we go. Give that an erase. Oh, I guess I got left it up there. Anyway, let's get back on the pen. All right, let's do these division problems. Looking over here, I got 15.9 divided by 0.3. The first number is the dividend, and it always goes inside the box. 15.9. This number is the divisor, and it always goes outside the box. Now, if the divisor has a decimal in it and it's not a whole number, I need to make it a whole number. It will make it so much easier. I'm going to move the decimal in one place to make it a whole number. If I do whatever I do on the outside, I have to do on the inside. So now I'm going to rewrite this to make it a little easier to see. I have 3, because I turned this into a whole number, into 159, and I move that decimal to the very end of the number. So now I can go through and just start dividing. 3 into 1 can't do. 3 into 15, however, goes 5. 3 times 5 is 15. Get 0, bring down the 9. 3 into 9 goes 3. 3 times 3 is 9. Oh, I get 0. Oh, there's nothing left to bring down. That's perfect. That decimal goes straight up. So this is my answer, 0, 5, 3, and then a decimal. That's kind of a confusing way to write this number right here, 53. I don't have to include the decimal at the end of a whole number, and I don't have to include any leading zeros in front of the number. So 53. This one over here, I got 8.4, negative 8.4 divided by negative 0.02. So I'm going to set my problem. 8.4 is the dividend. It goes inside the box. First number goes inside the box. 0.02 goes outside the box. Notice how I'm ignoring the negatives. The negatives only come into play whenever I'm trying to make sure my answer is correct. In terms of, is my answer a positive or a negative? That's the only time it comes into play, at least with division and multiplication. So I can ignore the negatives. I'll just check on them when I finish and get my answer. So let's look through this. This is a decimal. I want to make it a whole number. I'm going to move the decimal twice to do that. Whatever I do on the outside, I got to do on the inside. 1, 2. There's an empty space here. If that ever happens to you, you can fill it in with a 0. All right. So let me rewrite it. Now my problem is 2 into 840. So 2 goes into 8 4 times. 2 times 4 is 8. Subtract, I get 0. Bring down the 4. 2 into 4 goes twice. 2 times 2 is 4. Subtract. And some kids think that because they end up with a 0, they're done. But I moved that decimal here. If there are any numbers, including 0, in front of the decimal, I have to bring them down. So I'm not done yet. I have to include this 0. So 2 into 0, well, that goes 0. 2 times 0, well, that's 0 again. 0 minus 0 is 0. Now there's nothing left to bring down in front of the decimal. There's a million zeros back here, but I don't have to include those. All right, so bring my decimal up if I want to. Now my answer is 420. I don't have to include that decimal because it's a whole number. It's understood to be there. And that's all the problems from that decimal independent practice. All right. You guys, thanks for sticking around to the end of the video, and I'll see you in class.